linear systems by the addition method, also called the elimination method. Equations must be in standard form. You want to eliminate one of the variables, and you can do this when the coefficients of that variable are additive inverses. So for this particular example, let's eliminate the y variable because they are already opposite signs. So a least common multiple for 4 and 3 are 12. So if we multiply the first equation by 3 and the second equation by 4, then the y variable will have opposite coefficients. So the first equation becomes 9x minus 12y equals 33. Then we have 8x plus 12y equals negative 16. Adding these two equations together, we have 17x equals 17. Dividing by 17, we have x equals 1. Now if x equals 1, what we're going to do is you can substitute that value of 1 for x into either equation. I'll pick the first equation. So we'll have 3 times 1 minus 4y equals 11. 3 minus 4y equals 11. Subtracting 3, negative 4y equals 8, and dividing by negative 4, y will equal negative 2. So the solution is the ordered pair 1, 2. So there is one solution, which means we have intersecting lines. They are independent equations. And a consistent system. The next example, again we have two equations and we want to have additive inverses for one of those variables. So let's try removing our x variable this time. So we'll need to multiply the first equation by, let's say, a negative 3, second equation by 2. So we'll have negative 6x minus 12y equals negative 15. Then we have 6x plus 12y equals 12. Now when these equations are added together, the x terms cancel out as well as the y terms cancel out. So we have 0 equals negative 3. Well, no, this is not true. So that means there is no solution. These are parallel lines. They are still independent equations, but it's an inconsistent system. Last example. Again, we need to eliminate one of the variables. So let's try eliminating the y variable this time. So that means we'll have to, well, we don't need to multiply the first equation by anything, but we can multiply the second equation by, let's say, a negative 2. So the first equation remains the same, 4x minus 2y equals 2. The second equation becomes negative 4x plus 2y equals negative 2. Now what happens here is, well, x terms cancel, y terms cancel, even the constants cancel, and we're left with 0 equals 0. Well, yes, this is true, so that means we have infinite solutions. These are the same line, but there are dependent equations. A consistent system, because there are solutions, and we write these infinite solutions as all ordered pairs such that, and then you can choose either equation.